Hello, welcome back. We are into the eighth portion of our series through chapter 16. And this is the second part of determining the pH of salt solutions. In this video, we're going to talk through species that contain ionic species that contain one weak acid or weak base. And we're going to focus today on just having one of these species as part of the ionic solution. Stay tuned to the next video to find out what happens if we have more than one, and even the next video after that as to what happens if we have amphoteric species. Okay, so let's dive into our first example. Our first example is, do you expect a solution of ammonium bromide, NH4Br, to be acidic, basic, or neutral? And so our first step that we have to do is we have to see what happens whenever we dissolve the salt in water. And since we are talking about ionic species, when ionic species are dissolved in water, they break up into their individual ions. Now, the second step is to determine how the cation reacts with water. I don't know what I'm writing. So I'm going to look at the cation reaction with water. And the cation in this case is NH4 plus H2O. NH4 plus is a plus charge. It's going to behave as an acid, which means the water in this case is going to be a base. The base is going to take that proton, leaving us with NH3 aqueous plus H3O plus aqueous. And this is aqueous, and this is a liquid. Okay, so we have an equilibrium set up here. This means that we have a weak acid. This weak acid, this equilibrium reaction, is described by a Ka. So equilibrium reactions described by a Ka, and we know that only the neutral species is on our Ka table. If you haven't watched video number 6 that describes the Ka-Kb table, now would be a really good time to do that. And so we know that Ka, in this case, is going to be equal to Kw over Kb, and Kw is 1 times 10 to the minus 14, and our Kb for ammonia is 1.76 times 10 to the minus 5. And so my Ka for this reaction of NH4 plus with water is 5.68 times 10 to the minus 10. So now that I know how my cation reacts with water, I also need to figure out how my anion reacts with water. My anion in this case is Br minus plus H2O. And if it reacts, it would form HBr plus OH minus. But remember that this HBr is a strong acid. That means that this reaction that we just wrote actually does not happen. So our anion plus water is a no reaction situation because HBr is a strong acid. As soon as it forms, it automatically dissociates, and that means that my anion in solution is neutral, and my Kb doesn't exist. And so in step 4, we have to put it all together. So my cation, it is a weak acid. My anion is neutral. An acid plus a neutral in solution is going to result in an acidic solution. So I would predict that my pH is less than 7. And this is because when this ammonium bromide is dissolved in water, we get H3O plus resulting left over in the solution. And that H3O plus, that is what is making this solution be acidic. Okay, so here this is in summary. When I dissolve NH4Br into solution, it breaks up into its ions. For my cation, I see that it behaves as a weak acid, and so it has a Ka value, and it is acidic. The bromide forms HBr, which is a strong acid, which means that HBr does not remain in solution, and that hydrogen, this proton, immediately goes back into solution, resulting in no reaction, and my anion is behaving as a neutral species. And so, do we expect the solution to be acidic, basic, or neutral? Well, my ammonium behaves acidic, my bromide behaves as a neutral. A neutral plus an acid is an acidic solution, so I would predict that my pH is less than 7 when ammonium bromide is dissolved in water. Okay, so now I'm going to work through a second example that is of the same type as the previous example. And so in this example, I have potassium formate, CHO2. This is the formate ion. And so I want to predict if a solution of potassium formate is going to be acidic, basic, or neutral. And so to start off, in my first step, I have to dissolve in water. So my potassium formate is ionic, it's a solid. I dissolve it in water and I get K plus and the formate ion. And so step 2 is how the cation reacts with water. And so my cation is potassium. And if the cation were to react with water, it would form KOH plus H3O plus. KOH, this is a strong base, which means that as soon as it forms, it immediately dissociates. And so really my K plus my water is no reaction. And so when my potassium is dissolved in water, it creates a neutral solution. So now I need to do the same. Oh, and Ka is not applicable. There is no Ka because sorry about that. There is no Ka because there is no reaction. Okay, so step 3, I have to think about how the anion reacts with water. And in this case, I have the formate ion, CHO2 minus plus H2O. I have a minus sign, so it's going to behave as a base. Base takes proton, so I have CH2OH plus OH minus. This is formic acid. Formic acid is not one of our strong acids. It is a weak acid. And so we know that this, being the conjugate of a weak acid, is a weak base. And that means that this reaction can be described by a Kb, which is going to be K equal to Kw over Ka. Kw is 1 times 10 to the minus 14. The Ka of formic acid, let me look this up. I'm using the Ka-Kb table, is 1.8 times 10 to the minus 4. And this is equal to 5.56 times 10 to the minus 11. And so this solution, the anion behaves as a weak base. And so if I put it all together, I have my cation is neutral. My anion is a weak base. And so this is going to result in a basic solution. So its pH should be greater than 7. Okay, so in the next slides, I'm going to summarize what I've walked through here so that you can see it much more neatly and you can hear it again. Okay, so my formate ion, my first step is to dissolve it in water and break it up into its ions. I then look at how the cation behaves. And the cation forms this is a strong base. And so I know that the potassium ion is the conjugate of a strong base. Therefore, no reaction occurs and it behaves as a neutral species. Likewise, the formate ion for the anion forms an equilibrium with water, creating the formic acid, which is a weak acid. Therefore, this solution is the solution of the formate ion is a weak base. Or I guess I should say, the formate ion behaves as a weak base, producing a solution that is basic. And the reaction has a Kb value found using the Ka from the table. So what we get in summary is that the potassium behaves as a neutral ion, the formate behaves as a basic ion. A neutral plus a base is going to create an overall solution that is basic. And so the pH is greater than 7. Okay, so in our next installment, I'm going to talk about what happens if we have our cation is a weak acid and our anion is a weak base. And I'm going to walk through some more examples on how to predict the pH of these solutions. Okay, so keep up the good work. Keep asking lots of hard questions. I'm available for office hours and all sorts of help. Reach out to me if you need me. I will see you in the next video.